Um, Matter that is dark.
Dark matter does not emit, absorb, or interact with light, yet it is affected by gravity like conventional matter. Following the Big Bang, it has been slowly clumping into chain-like forms. Regular matter accumulates where these chains intersect because gravity is strongest there. Regular matter and dark matter are both subject to gravity, but they do not interact. Billions of dark matter particles are passing through the Earth at any one time.
Um, Gas. Um, Maybe atoms and different particles that come together that create energy in some form or another.
Actually, normal matter and energy that we can detect only comprise about 5% of the total universe. 24% of the universe is dark matter, and the rest is comprised of dark energy, another recently discovered force.
I would say that dark matter exists because you can look in our universe far from the Earth and tell that there's a lot more dark space than light.
Dark matter is assumed to exist, but has never actually been directly observed. In the 1930s, Fritz Zwicky collected luminosity measurements of galaxy clusters, which suggested a certain mass. When he calculated the cluster's average orbital velocities and used Newton's law of gravitation to predict mass, that calculation was vastly higher than what the luminosity suggested. He realized there must have been much more he couldn't see. In the 1950s, Vera Rubin measured orbital speeds throughout galaxies, expecting stars closer to the center to orbit much faster than those towards the edge. Strangely, everything was orbiting at a uniform speed. Theory suggests that dark matter is acting like a halo around visible matter, keeping galaxies from flying apart.
The lack of matter. Nothing. Maybe like a big explosion or something.
Astronomers believe dark matter to be comprised of exotic matter, a variety of subatomic particles not found in ordinary atoms, which don't interact with light or regular matter at all. We've discovered many exotic particles, but added together they do not account for the full amount of dark matter in the universe that we believe to exist. Scientists have theorized about other kinds of exotic particles, which could be the missing link, but have not yet directly detected these new particles.
With the technology these days, I'm sure that NASA or one of the other organizations has found a way to successfully trace dark matter. I don't quite know how they do it, whether it be like satellites or um, some sort of I wouldn't know how they do it, but I would assume that now we have a good depiction of what dark matter is and how we can find it.
Scientists are currently attempting to detect dark matter using highly dense pads of germanium. They cool these pads to near sub-zero temperatures and place them in underground labs to prevent interference from conventional forms of light. The theory is that very occasionally, a dark matter particle might collide with the nucleus of a single germanium atom, very slightly raising the temperature of the pad. Scientists must analyze recorded data to weed out the interactions caused by other exotic particles, such as neutrinos, quarks, leptons, and bosons. So far, we have not yet detected the missing dark matter particle.
Don't know.
The universe began expanding due to the initial force from the Big Bang, but its expansion is now accelerating due to dark energy. Dark energy comprises the rest of the universe at a whopping 71.4% of the total makeup. It acts as a repulsive force, somewhat like the opposite of gravity. Since dark energy is a property of space itself, it becomes more abundant as space expands. The acceleration began 5 billion years ago, when the universe had expanded enough that the repulsive force of dark energy could overpower the attractive force of gravity. There will reach a point where acceleration is exponential.